Right, so what we're looking at here is the structural deflection calculated on SolidWorks for the beam deflection, and we'll go onto the vessel just now to show you why we had to go through all this trouble to actually get the beam to carry this load as far as the space saving is concerned. Chris, if you can just throw a little bit of numbers for us before we go onto the vessel.
Well, basically I used the comparison of a composite beam, and this is on the von List scale. We basically got 15.8, roughly maximum 15.8 megapascals of stress, and the displacement at that load, which is a 2.5 ton point load in the center of the beam, would only constitute a deflection of about 11 millimeters, which is well within the specification of a beam of this length, of which you can go up to 1 to 2% of the beam depth, which is roughly 200 millimeters in this instance. So it's way within the specification of where we will be. And also it's a way overestimate of the load, because in my opinion, I don't think by the time you get to a 2.5 ton load on the downward load on the mast, additional to the strain in the shrouds, you've got serious problems, serious weather. This is,
maybe if I can just add on there, that is not taking consideration the composite roof skin, the additional longitudinal beams. We'll go onto the vessel now and have a look at that as well. Right, as you guys can see, why are we doing all this extra work and beams and calculations? And it's quite simple. Being a smaller vessel, as you guys can see, both of us are standing in the saloon area now, and what we achieved by doing this is we got a 8-post situation carrying the mast, and we don't have a center column that normally would happen in catamarans down to the bridge deck and the reinforcing under the bridge deck. So it serves two purposes. Firstly, your beam to carry the crossload between the hulls is now in the roof section. We have space anyway of the ceiling, and you don't have to thicken up the bridge deck floor to carry the mast loads, which gives you then extra head clearance and extra freeboard under the bridge section.
And the supports, the base support of these this H-frame is basically on a very, very strong point on the boat, where it's curved and with an extremely strong part of the hull that these beams tie into.
Yeah, so all this extra engineering and thoughtful process was just to open up more space. And Chris, I feel we have been very successful.
Yes.
With achieving our goal, being a smaller 10.5 meter vessel. Our real estate in the saloon is phenomenal.